All right, so 4.5 is very similar to 4.4. It's actually pretty much exactly the same, except the drawing the diagram is going to be more complicated because now we're working in 3 dimensions, not 2. So visualizing it, understanding or seeing right angles, these things become more difficult in 3 dimensions, and you'll see why. So here I drew not a piece of cheese, but this is a cliff with a river running through it. Here's some grass on top of the cliff, just so you can visualize it. Now, I'm not an artist. If you're not an artist, that's fine. Do whatever you have to do to kind of visualize 3 dimensions. So I have this dimension going up, and the water is flat. Now, if I was here, and I wanted to find the height of the cliff, but I'm on this side of the river, this is possible using trigonometry, and I'm going to show you how. So what we have to do first is put a stake in the ground over here. I'm going to call this point A. Then I'm going to measure a second point, and I'm going to call it B. And I can figure out the distance of this because I'm on this side of the river. I can measure this, and this is 150 meters. Now, I'm going to find a rock at the bottom of this cliff, and I'm going to measure the angle from point A to that rock, and I'm going to measure the angle to that rock from B. And I'm going to measure this one to be 51 degrees, and this one's going to be 62 degrees. Okay, so far pretty easy on what I can do here. And we'll call this point C. Now, where this becomes difficult is I'm trying to find the height of this cliff. I'm trying to find this guy right here. Okay, I can find the angle using a tool you use in physics. If you look through a straw and you have a protractor and just have a weight hanging, it'll tell you what the angle of elevation is to the top of a structure. And I can connect these two like this. And I know that this angle in here is 32 degrees. Okay. And I know that this angle is a right angle, even though it doesn't look like it, because it's the height of a cliff, and height, vertical and horizontal, are always perpendicular. It's always a right angle. Okay, so this information is what I can find from this side of the cliff. And now, the trick to solving three-dimensional trig is finding the common side between the triangles. So these two triangles share a common side. That side is AC. So AC is going to be a very, very big priority because it's going to help me transfer the information from one triangle to the other and work towards the answer. Notice the information is on this triangle. I need to work my way to H. So I have to give some information to this triangle and solve for H. So how are we going to do that? I don't have a right angle triangle here, so I can't use SOHCAHTOA. I see I have 2 angles, which definitely means I have 3. So I'm going to solve for that angle, angle C. Angle C is 180 minus 51 minus 62. Angle C is 67 degrees. Now, I have 3 angles, but more importantly, I have C and C. I have these 2 side lengths. It tells me right away that this is Sine Law. So I can use this ratio, full ratio, to solve for the angle of B. Not the angle of B, sorry, it's buddy. It's side length of B. And I'm going to use sine ratio of B over sine B. Remember, I always start with the one I need on top. And I'm going to use C over sine C. B over sine of 62. And 150 over sine of 67. I just found that out. I can solve here. This is going to be 150 sine 62 over sine 67. Pop that into your calculator and you're going to get 144 meters. I'm going to box that because it's a key point. And now I know that B is 144. Now, if you look at this triangle over here, now that I'm transferring that 144 into this triangle, this is a right angle triangle. That's amazing because now I can use SOHCAHTOA. I have an angle and a side length. Anything is possible in a right angle triangle with those 2 pieces of information. So if this is my angle, I'm looking for the opposite side. I know it's labeled H, but the hypotenuse is this right here. Opposite, and I have adjacent. This is tan. Tan theta equals opposite over adjacent. Tan of 32 equals opposite over adjacent. Okay, so I've replaced everything that I know. Now I have to solve for H by multiplying the 144 up here. Pick up your calculator, 90 meters equals h. So therefore, the height of the cliff is 90 meters. Okay, pretty cool actually, because if you were actually here and you were a land surveyor and you're on one side of the river and you have to figure out the height of the cliff, there's no way of doing it. I mean, I'm sure there's an app to do it now, which actually probably in the background of the app has this, right? A programmer who programmed that app definitely has this written in his code. But it's kind of cool to understand that we can do that from this side of the river without any tools or crazy instruments besides this inclinometer, whatever you call it, to find out that angle. Otherwise, pretty straightforward. Now, problems in 3 dimensions, again, are the same as 4.4. You have to use sine law, you have to use SOHCAHTOA, you might have to use cosine law. You guys always struggle with the cosine law, so make sure you ask questions, and I'll make a separate video with cosine law answers. But the only trick is drawing the diagram. That's like 8 out of 10 difficulty, as long as you know your 4.4 stuff. And then it's just sine law, cosine law, SOHCAHTOA, Pythagorean theorem, all these skills we have to solve for triangles, working our way towards the answer. And that's it. That's problems in 3 dimensions.